The next type of function that we're going to talk about is continuous function versus discrete function. So in one of the videos, I talked about how sometimes when you graph, you're going to just have dots, and sometimes when you have graph, you're going to have connect the dots with the line. That gets into discrete and continuous. So the easiest way to tell if a graph is, or a function is discrete or continuous, is if a graph is continuous, that means you are going to have a graph with a smooth line, or it could be a curve, doesn't have to be a straight line, connecting data points. So in that case, you could have a graph and it looks like this. And again, it doesn't have to be a straight line. These are all data points. And then if it's continuous, it's a line that's connecting them. Next option would be discrete. So a discrete graph is a graph without connected data points. In that case, you have data points and they're not connected. So again, a continuous graph is going to be a graph that has data points that are connected, so you have a line. Discrete is going to be a graph where there's no line connecting the data points. Now it gets a little bit deeper than that. So I want you to think about what potential x and y values might be on some of these graphs. And in particular, we're going to look at the y values. And I want you to think about, okay, if I'm talking about y values, what type of variables we're talking about. So if we are talking about continuous information, you want to think of continuous information or continuous variables as measurable, whereas discrete is countable. Let's clarify that a little bit. So if I'm looking at a continuous graph and I'm looking at my y values of my continuous graph, I'm talking about things like weight. I'm talking about things like height. I'm even talking about things like money. And in a continuous graph, you can measure those things. So you can measure weight, you can measure height. And in a continuous graph, your answer could fall in between two whole numbers. So someone's height, it makes sense that someone might be 5.5 inches, or not 5.5 inches, 5.5 feet tall. It makes sense for you to make $325.72 working at a restaurant over a week. Makes sense to fall in between whole numbers. If you go over to discrete data and you think about a graph and you think about the y values of discrete data, you're going to think about things like number of students in a classroom. Maybe the number of Skittles. I don't know how to spell Skittles. I think that's spelled wrong. Ignore the spelling wrong of Skittles. In a bag. In both of these situations, these variables, it doesn't make sense to have a number that's in between two whole numbers. For example, if we're counting, again, the number of students in a class, you're not going to have 25.5 students. You don't usually have half of a student. If you're counting the number of Skittles in a bag of Skittles, usually Skittles doesn't sell you 3/4 of a Skittle. There's, 25 in a little bag of Skittles. I don't know. So if you are talking continuous data, it's measurable, and that means that it can fall anywhere between where you start your points and where you end your points. It's any of that information in between. Anything on that line is part of the graph. Whereas discrete data, you do not have a line connecting your data points, and the only points of data are those specific points that do not have a connecting line, meaning you can't have anything in between the data points. It's just those specific data points. There's nothing that falls in between them that is on the graph. One more time. Continuous, smooth line. Discrete, not a smooth line. Continuous, you can measure. Discrete, you're counting. Make sure you're checking Google Classroom to figure out what you need to be doing next.